Hello chicos, today we're gonna do lesson 1, review on polygons, triangles, transversals, and proportional segments. Remember that we talked about how polygons means many angles. And there are 3 important characteristics. They are simple, closed, flat geometric figures with straight sides. So we have to remember that. Now I want to show here some non-examples, okay? What are non-examples? Things that go opposite or that are not examples of what we're talking about. So in that case, the figure doesn't start and end in the same point. So it's not closed. For that reason, it's not a polygon. Then we also have, for example, in an oval or a circle or any kind of shape that has a curve is not a polygon because it doesn't have straight sides. And then if we have something like this, that's not simple because it's formed by 2 triangles. So that wouldn't be a polygon either. And then finally, if we talked about, for example, about a cylinder is a solid, a geometric solid, which means that it has 3 dimensions and is not a polygon either. Now here are the names of the polygons. Remember that they get the name because of the number of sides that they have. So a 3-side polygon is called a triangle. If it has 4, it's a quadrilateral. If it has 5, it's a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 11 is an undecagon. 12 is a dodecagon. And then after that, we just put the number and gon. For example, 13, gon. 15, gon. 20, gon. Now, remember that triangles are classified by their sides and by the angles. The first here that we have is by the sides. An equilateral, remember, means that it has all 3 equal sides. And we use those little lines to say that those 3 sides are equal. Isosceles has 2 equal sides. And then scalene is that it has all different sides. So that's why we put different lines. In one we put 1, 2, and 3 to say that they're all different. We can even put one here to identify that that one is different. Then we have the classification by angles. And in this one we have the right triangle, which is the triangle that has a right angle. Then we have acute triangle, which it has all of the angles are acute. And then in the obtuse triangle, it has an obtuse angle. And obviously, the other 2 angles are going to be acute. The same happens with the right angle. These 2 have to be acute because they have to add up to 180. Now remember that a right triangle can only have 1 right angle. It can never have 2. And an obtuse triangle can only have 1 obtuse triangle. It can never have 2. We're going to look at these examples. In this first example, it says find x and y. Again, we have to remember that the sum of all 3 angles is 180. And knowing that, we're going to solve that. Now, we also have to realize that we have these 2 lines here, which means that the triangle is isosceles. When we have sides that are equal, then the opposite angles are also equal. So this angle and this angle are the same because they're opposite to the 2 sides that are equal. So I can say that x equals 50. And since x equals 50, then I know that these 2 together are going to be 100 because it's a 50 plus 50. And so for y, I just have to subtract 180, which is the sum of all 3, minus 100, which is the 50-50, and that equals 80. So y is 80. Now notice that if I also want to classify these, I already know it's isosceles. If I want to classify by the angles, I have 50, 50, and 80. That would be an acute triangle. Then we have example 1.2. Again, it says find x and y, and it gives us this drawing. Now notice that what we need to find first is this x. Why? Because we know that all of this is 180, so we can find what x is. And how do I know that is 180? Because it's a straight angle. Remember that a straight angle is 180, and so 150 and x are supplementary. So I just subtract 180 minus 150, and that equals 30. Now that I know that x equals 30 and the other one is 40, then I know that y is going to be 180 because it's the sum of all three angles minus 30 minus 40. And that equals 110. In this case, since we have y is 110, then this one is an obtuse triangle. So if we have one obtuse angle in the triangle, then the triangle is going to be classified as obtuse. And notice also that since they all are different, all the angles are different, then I know that all the sides are different, which in that case would be scalene. All right, next we go with D. Notice that in this one, what kind of triangle is that one? That triangle, all sides are equal, so that one is an equilateral. And equilateral means that these angles are all the same, which if we divide, 180 divided by 3 is 60. You can also know it by memory that the equilateral triangle has three 60-degree angles. So to find D, notice that we do the same thing with the straight angle. This is 180, and 180 minus 60 is going to be D. So D equals 120. Now we're going to review transversals. Remember that a transversal is a line that intersects some other lines. So in these drawings, the orange line would be the transversal. Okay, now notice that in this one here, it's just any random lines. But in this one, they are parallel lines. So the transversal is cutting two parallel lines. And when that happens, that's very important because we can work with the angles. These angles are all the same. And the other angles, let me mark it here, they're also the same. So the purple angles are all the same and the green angles are all the same. How do we know which one goes with which? Well, notice that there's some that are acute and some that are obtuse. So all the acute angles are the same and all the obtuse angles are the same. Another way to see is that they go in the same direction. So notice, for example, how this one and this one goes in the same direction. And if I see the purple is going in this direction. So we can see that they are opposite to each other. Notice also that they are opposite to the vertex or vertical angles. So let's look at example 1.4. In that one, they give us a transversal that is cutting two parallel lines. Okay? And so we're going to start here, 60 and A. If that one is 60, this is 180, then I know A is going to be 120. Okay? And so now I just see that A and B are both obtuse, and so B is also 120. And then C goes with 60. And that's it. That's all we have to do. And notice that if I keep going, I can just say this is also 120, this is also 60. This is also 120 and this is also 60. There's nothing else. There's no any other options or calculations. Those are the only two values for this example. Okay? Let's continue with the next one. Proportional segments. So proportional means that they have a relationship in the way that they grow or that they exist. And what you have to remember is that whenever we have parallel lines, these are parallel, and we have transversals, we have to have two. What is going to happen is that this segment, notice that's not an angle, that's a segment, it's this little piece, over this one, so I'm going to put it like that, 2 over 5, equals the same as this segment over this one. So 8/3 over x. So how do we find x? We are going to multiply in cross. We're going to multiply these two and then divide by the 2. So it's going to be 5 times 8/3 and then divided by 2. Now remember, when we divide, we have to multiply by the reciprocal. So it's 5 times 8/3 times 1/2. We multiply by the reciprocal of 2. And so in this case, if I simplify that, x is going to be, I can simplify the 8 and the 2. So here's 4 and here's 1. And if I multiply that, then it's going to be 5 times 4 is 20. And then over 3. Okay, so those are the 5 examples for this lesson. Make sure you go do your practice, do your best. And if you have any questions, please let me know.